Hello and welcome to this video about platformer in Godot. I know there are many other videos in platformer in Godot around the internet already. I'm going to make my own as a basis of many other things that are coming in the near future. In this video, what we are going to implement is a tile system, which is basically a way to develop these kinds of levels. It could be top-down also or sideways, as I'm showing here. And we are also going to use GD script with physics to implement the jumping mechanic, the collision mechanic, so that the character will fall onto the ground, and also a little final goal screen in which you'll see I won. In the next few videos, we'll also implement other things such as enemies and dying and lives, but currently, as you see, we have not. So let's get to it. So first things first, we're going also to use another piece of software to be able to draw things and use sprites in our game. You may use many different kinds of software. In my case, I'm going to use Sprite. This is a paid software to draw pixel art, which you can buy, you can try it now, but at the same time, this is also an open source project. So if you are up to the task, you may also just clone the repository and build it yourself. This is actually what I did. Eventually, I'll probably buy it once I have more money to be able to pay the license. But if you don't want to try something like this, you can also, for example, use Paint.net in Windows or GIMP in Linux or Mac or Krita or many other different pieces of software to be able to draw things. Sprite is just a little bit more convenient for pixel art. So I created the project in my Godot game engine. I created a project named Episode 3, Simple Platformer, and this is what we are going to do now. To start off, the first thing that I'm going to talk about is the level and level design. So since this is a platformer similar to, I don't know, Mario, Mega Man, and these kinds of games, we can imagine that there's a side-scrolling effect. The character would be here and walk to the right, and the level would be drawn around him. So how do we actually draw this level? You definitely can draw it entirely by hand, but let's use the engine to help us do this. The node we are going to use to do this is called TileMaps. So there's the 2D version, which is called TileMap, and there's also the 3D version called GridMap. So we are going to use the 2D now, obviously. So TileMap over here, and you can already see that my space is tiled now with these little orangish lines. And we can use this tile setup to be able to draw things on my screen. So to do this, I'll click on the tile here to the right, create a new tile set, and I'll click on the new tile set. And now I have the configuration over here to the bottom of what my tile set is. Here I will be able to specify the different tiles that I have, which may be, I don't know, ground or cloud or maybe trees or different types of ground, even depending on the shapes you have. In my case, I'm just going to drag and drop this icon to showcase how it works. I can click here on my quote-unquote first tile or first image that I just drawn. You can add more images using this. And in each image, you may also have multiple tiles. In my case, if I click Edit and click New Single Tile, I'll just say I want a single tile. I want to draw a single tile from this image. I can also draw multiple, but in my case, I'm just drawing one. I also click here in the snapping configuration. If not, I can just draw anywhere. With the snapping, I'm able to draw specifically what I want. You can also go here to the inspector settings and change the snap options in case you want a different pixel step or separation or whatnot. So in our case, I'm just going to select this as our tile. It will get exactly the bounding box of this specific icon, and And now I'll just save this node, and I'll have a main here, which is what I previously named it. And from here, I can click on TileMap. You'll see the tile that I just configured over here. And with this, I can just draw around my screen and say, just draw a little square, maybe a larger square coming over here. I have somewhere that I can fall to my death, somewhere that I want to jump over, and maybe something like this. And this would be my end eventually. Oops. So if I run this, set my main scene as my main scene, you'll see that I'm not actually seeing the entire level here. This is because you remember a few videos ago, I talked about what is these lines over here, the blue line here, and there's another one behind it, which shows what are the bounding boxes of the screen when I actually run the game. What I'll do eventually is make everything move using the transform. I can change the position and make everything move, or even move the viewport itself, which is basically moving the bounding box to the right. So there are two possibilities. We'll do one eventually. So fix this pretty fast. And we now also want to add a character. So let's go to a sprite, create a new, let's say 16 by 16. Okay. And I'll just draw some little thing over here. And I created a little character for me here. I'm terrible at drawing, so sorry about this. But if you're good at drawing, feel free to draw the main character of your dreams if you wish. I'll go here to File, Export, or Save As. You can, I think Save As is the fastest way to do it. And PNG, I'll just overwrite this main character that I had previously. So with this, now I have a little sprite over here called main character. I can drag and drop. And as maybe you remember from the first tutorial, this is a sprite node. A sprite node will have a texture, and if I scale it, here it is. I also need to change one configuration, which in my case is already changed, which is this filter over here. By default, this is tagged on, which will make the sprite very blurry, which is not what we want. We actually want a proper pixelated feeling. So this is how we're going to do. And also I'll change the transform to scale 5 and 5, just to be more say normal numbers over here, so it's easy to remember. With this, we have a little sprite for our main character, but if I actually run this, obviously nothing will happen. I need to now make my character either fall and make sure that there's collisions working between the character and the level around it. So to do that, first I'll create a new scene with the main character as a root node. So what I can do is just right click and save branch as scene. I'll call it main character. And now I have the main character scene, which is over here. Okay, so what I'm going to do here is just put the position back to 0 and make sure that the position is actually in this scene. I don't want any position changing over here. Now let's add physics. We'll talk about a little bit about physics. So in the childs, in the possible nodes that Godot allows you to have, there are the physics type nodes, in which among the 2D nodes you can find collision object, where we'll show every node that handles possible collisions. Area 2D is the most basic one. It's useful for you to check if there is a collision or not, but just that. And the physics body 2D nodes helps also you to slide between two physical bodies, for example, or apply gravity, apply forces, or those kinds of things. Static body is wonderful for walls, things that are not movable. Rigid body for entities that require proper physics with forces and rotation and that kind of stuff. And kinematic is, as you can see to the left, is the one most suited for player movement. Just as an example, let me make this actually a rigid body. I'll right click here and make this the scene root. Just make sure that the rigid body is above. And as you can also see here, there's no shape configured for this node. Every physics node needs also a shape, so you can just add a child node, and among the possible shapes there are collision shape 2D and collision polygon 2D. Collision shape are for simple shapes, for example, a circle, a rectangle, a square, something like that. And polygon, we actually can define what are the exact points or exact vertices that you want to specify for your collision. In my case, I'll just make a simple collision shape. To the right here in this inspector, I'll create a new rectangle, and I can just drag it to make sure it matches my little character. Looks good. So if you notice, I'm using a rigid body and not a kinematic body for now. If I click on rigid body to the right, I can see all the different parameters that I have for the rigid body. There are many types of modes. Maybe it's a kinematic mode or a rigid mode, depending on what you want. I can go through eventually what are the differences, but the main thing is that you can specify mass, weight, more information through this thing, like gravity and so on and so forth. If I merely have this and run back my main scene, you'll notice that the little guy will fall. But it's falling to this abyss because the tiles have no collisions themselves. So let's do this and make sure that the tiles have collision. To do this, we'll go back to the tile set over here, click on the image that you have. Maybe you have multiple already. Click here and make sure that to select the collision. So you can specify what is the region that you're drawing. Now you can also add a collision. Again, you can specify collision shape or polygon, just as the nodes over there. I'll just make a square and make it match exactly what is being drawn. If I save now and run, my little guy stops. And to show the differences between rigid body and kinematic body, if I right click and change type, change it to kinematic body, you'll see that nearly all the options went away. This is because the kinematic body has no notion of forces and weight and mass and gravity. So these kinds of things, if you're using a kinematic body, you'll need to implement yourself. Depending on your game, maybe you want one or the other. For example, if I want my jump to be very Mario-like, like without any acceleration, maybe I want to implement my own. So I use kinematic body. But then you can also use the rigid body in the kinematic sense and use information as a material and have a proper physics-enabled jump. Depending on what you want your game to be, you may decide to use either one or the other. But also notice that if you do set this as kinematic, if you run the code, you'll notice that it's not falling anymore. So if you go to the developer website and information about the rigid body 2D, here are the possible modes. In the kinematic mode, the body behaves as a kinematic body 2D and must be moved by code. So it's basically saying that my character is now a kinematic body, essentially, but it also has this information which I can also use. So yeah, it's pros and cons maybe. In our case, for our tutorial, we'll just be using the kinematic body and implementing ourselves. So let's do this and make sure we have a script in our main character. And what we actually want to do here is for the process, which is called every frame. As you can see here, every frame calls this function. I'm not sure if I talked about this in previous tutorial, but if not, know that process is called every frame. If you have a very good machine, maybe you're running many frames at the same time. So you use this delta to make sure that you abstract the idea of how many frames you're using, and you multiply whatever changes you're doing to your, say, my sprite, my position, by this delta, so that a slow machine and a fast machine would see the same changes in speed and position of your character, irrespective of the frame rate. So back to what a kinematic body or a physics body is, we can come here to the documentation, and you will see that the kinematic body has these functions here: move and collide, move and slide, and move and slide with snap. Move and collide is wonderful for when you want to move and make sure you're not colliding with something. If you collide, you stop. And move and slide is a little bit different. You move, and if you hit something, you'll slide. Maybe it's some inclination or like a slope or something. If you move to the right onto a slope, you will go up, or something similar to that. For example, let's use move and collide for now. You'll notice that we just call move and collide with a vector. Everything else we'll just use as default. So let's put it here. And now I included move and collide, making sure that I'm going to the positive y direction. And if you don't remember, here in my scene, in 2D, my x will go to the right and my y will go down. So it means that positive y is going down. This is why I'm multiplying and making sure that my position over time will go down in my script. So I multiply my delta by a downwards vector, and you'll see my little character going down, but very, very slowly. So to fix this, let's include also another variable which we'll call gravity. We'll just multiply by 50, say my gravity is 50, and now I can see it's falling much more smoothly. Maybe 150 is more like it. Let me move a little bit upwards. Yeah, it's fine. I guess 200 for now. So I've tested out my gravity. I made sure that my gravity is reasonable compared to what I want. I can also expose or export my gravity. I'll just call var gravity. And I want it to be by default 200. Notice that I put a little colon with equals. If I just do equals, this gravity will not necessarily be a number. If I come, for example, here in ready and try to make it a string, Godot will actually allow me to do it. But if I put a colon, it's basically saying my gravity should always be a number. So I can't actually change it to a string. So if I do this and come back here in my inspector, click my main character, to the right I'll see gravity, and I can type some other gravity over here as well, so that maybe I can change the gravity per user, or maybe per level I can edit this variable or something like that. So I have my gravity, I'll multiply it over here, gravity, and everything is working properly. The next step now will be to accept inputs from the user and make sure that, for example, if I click A or D, or maybe the arrow keys to the left and right, I move to the left and right. To do that, we'll go to projects, project settings, input map, and we'll see all the current inputs already accepted and configured in Godot. The ones that I actually just added was in this UI left, right, up, and down. I clicked here, add a key, and I added A. Let me do one, for example. I'll just click here, here, and click A. Okay, A is here. Now, if I check if my UI left is pressed, I can at the same time verify if I'm pressing A, left, or D-pad left if I have a controller connected to my machine. So this is like very good, so that you can abstract what is my input type and what I'm actually checking in my game. So what I can do here is just check whether if my input action pressed UI say right. So if my action press is pressed, I can say I'll just move again to the right. So 0 and positive X. And no, it's not action press, it's is action pressed. Now that's much better. If I run this, you'll see I can type D or to the right, and both of them will move our character to the right a little bit. So it can do basically the same thing for everything else. What I'll do actually is just call move and collide once, because it's better to call it only once for performance purposes and also in general. So say my velocity is a vector 2 times delta times gravity. So by default, my velocity is this. I'll move it by this velocity at the end, and right here I'll just say my velocity X should be a little bit bigger, maybe +4 for now. And you'll notice that now this is not working properly, the same thing that I did over here, because since I'm doing this multiplication, Godot doesn't actually know what type of value this should be. So what I can do here and just say this is actually a vector 2 value and it's equal to this. So now I'm sure that this variable is of type vector 2. And with this, can also do the same thing for UI right. Left, I mean. UI left, and do this -4. So if I run, you'll notice that if I go to the right and left, the main character is very slow. Let me run it again. If I try not on the ground, it's fast, but now on the ground it's very slow. This is the main difference between move and collide and move and slide. You notice that I'm trying to go down here. I'm hitting the ground, and since I'm running move and collide, Godot internally is just saying, okay, I collided, I actually shouldn't move anything. So this is why when I'm at the ground, I move left and right much less. So this is where move and slide comes in. So move and slide is a little bit different. If you go to the documentation, you notice that it also has a lot of more text compared to the move and collide. You can go through it to understand a little bit more about it. You'll also notice that this method should be used in physics process. So physics process is different from process, in which the process is called every frame. Physics process is called every physics frame, kind of. So every pass of the physics engine will call the physics process. And so we'll change this to physics process. We'll change this to move and slide. And now you'll also notice another problem in which it's very slow once again. So move and slide works much more slowly compared to the move and collide. So just multiply everything here by 100. And you'll see now everything is reasonable again. It's moving to the right and left as we expect as well. And before I forget, the velocity will also need to be changed with the delta value. So remembering the frame rate thing, and this is very important so that the velocity X doesn't change depending on the frame rate. So because of this, delta is very small, and our gravity was something like this. We'll need to make our velocity just as big, more or less, as the gravity is. So if we do this, now everything works properly, and we also are frame independent, which is all very important. So the next step now is to do a jump. To do a jump, we'll do basically the same thing. We'll check for UI up, and we want to actually change the Y in the negative direction, which is up once again. And let's say if while I'm pressing up, my velocity will just go up by this amount. That's fine. Let's see what happens. If I jump up, I'm actually just basically hovering. It's not exactly what I want, but it's something, right? So to give more flavor to our jump, what I'm going to do is I create a new variable here saying what's my max jump. I can even export it maybe. And I'll say the max jump is something pretty high, something like this. And I'll even export it to edit if I want. So my max jump will be this. I'm going to add this here, kind of. But instead of just doing my max jump, while I'm pressing, what I want to do is that my current jump, which starts out being the same as a max jump, will be added here and then divided by 2. So like this, I can just say, just divide itself by 2 and associate to the current jump back to what the current jump is. And once the UI up is released, is just released, so I'll check if my UI up was just released. If I do this, my current jump goes back to max jump. And my P is missing all over. P here too. With this, we probably have something very interesting happening. Maybe divided by 2 is too much. Let's say divided by 1.2. So it eases much slower, maybe less 0.5 or something like this. You notice that I can jump at any point. Not exactly what I want to. I want to be sure that I'm at the ground while I'm jumping. So to do this, we actually can just check if I'm at the ground or not. Let's do this now. And here's the solution to, or one of the possible solutions to do this ground check. So I created a new variable here, just to check if I'm on the ground. By default, I'm not on the ground because I'm floating. It's where I start in the scene, right? So I only allow for me to do the upwards movement if I'm on the ground. And I also, when I release, and only when I release my up or W key, I actually update the ground to be false again. And this here, this is a very interesting method from the kinematic body. Can just come to the search and we'll see get slide count returns a number of times the body collided and changed direction during the last call to move and slide, which means that I first need to call move and slide, and then I check, did I actually collide with something? Eventually I'll need to check what I collided with, but for now everything that I collide with is part of the scene. So for now this is good enough. And I check if I collided with something, and also if my velocity is positive, which basically means I'm going down. And if I'm going down and I collided with something, it means that I am on the ground. So if I run this, it's a very basic, but now I can't actually jump, but I can jump from the walls still, because like everything here is counted as ground because of this get slide count. Next step, maybe you want this this wall jump as I did. I can even say ceiling jump, kind of, if I do frame perfect hits while I'm on the ceiling. But what I'm going to do now is, instead of having one single tile doing everything, I'll have two separate tiles, one for the ground where I can actually jump from, and one from the walls, which I actually can't jump from. This is like my way of solving it. You can also solve in different ways, but since I will also have different sprites or different images for my walls and my ground, then I think this is good enough for me. So let's go back to the drawing board and draw some walls and grounds. So yeah, I came back to my A sprite. I just drew some little ground texture where I have a little bit of grass, and a non-ground texture, which is basically just a blank box with, I don't know, dirt maybe. Who knows what this is. So back here, I'll go back to my tile map, tile set. I'll make sure to include these two other sprites that I just did. I'll add a new single tile, and you notice that now my sizes are much different, right? So I'll need actually to change some different configurations. For example, in my snapping configuration, I'm not actually matching it anymore. Just so you know, these two were made with 16 by 16 again. So I'll just come to my tile set. And I also need to click here in single tile to make sure I will actually draw something. And now my snap options are here. So it's not 32 by 32 anymore. I'll just put 8 by 8 so that I can select like this. So this is my region. This is my collision. Here we go. And my ground, same thing, single tile. This is my region. This is my collision. Oops. So going back to here, let us change our sprites to match what we just drew. So instead of using this one, I'm using this one over here. You notice that this is definitely not right. My cell size now should be different. And to fix that, I'll just come here to the cell size. My cell size now is 16 by 16. You'll notice that everything actually was reduced by size. If you wish, you can just use it like this. I'll just, in my case, I'll scale by 2 right here in the Node 2D transform, and I'll draw the blocks now once again. Delete everything. And now my new blocks with this beautiful texture that I just did will be included. I'll finish this off and come back soon. And now we have our scene drawn. You can draw any type of level if you like. In your case, in my case, I just draw something very simple. I want to go up here and then finally finish the level over here. So now I will use this opportunity to talk about area collisions, because you notice that I'm able to jump from walls, and it's not exactly what I want. So I choose to do this way just so I can explain a little bit more about collision shapes and masks, which if you come here to the collision shape or to the kinematic body, actually, you can see here every physics body 2D has a collision type, which has layers and masks. You can either choose from here or click over here. This basically will mean, say, if my character is in the layer 1 and has mask 1, and also back here in my tile map, which also has collision, right? Layer 1, mask 1 means that they will try to collide amongst themselves. So Godot will try to check everything that is within the same layer and mask. So if I change the layer mask over this one, it's not doing that anymore. But what is the difference between layer and mask? So if you hover over, it will tell you about it a little bit. So the collision layer, collision mask, yeah, it's not very helpful. Basically, what means is the layer and the mask is one way or the other. So the layer of one will match on the mask of the other, and vice versa. Which means that if, for example, if this one is in mask 1, layer 2, and main char is on the opposite layer, I forgot already what I did before. So say layer 1, mask 2, layer 2, mask 1. If it's like this, everything will work again as we had before, just because the layer of one is matching the mask of the other. If I'm making everything sound very confusing, you can just imagine everything like this will be matched together. But for example, if I have another character, another thing that I want only to check with TileMap, but not with the main character, I can add to the TileMap something else, for example, the second layer and mask. And on this second thing, I only have, say I have another character, which is over here now. And this second character in the collision, it is only on the second one, which basically means the two characters will not collide with each other because they are in different layers and mask. But the tile map will collide with both because they match. So if I actually run this, I can do everything. Both are colliding with the tile mask, but they can actually run into each other. So this is important because what we'll do to exemplify this process that I'm trying to showcase here is I'm actually adding another collision shape here, in which will be area 2D. So the area 2D also needs a collider, collision shape 2D, which will be again a rectangle. I'll put this rectangle on the bottom. Oops, I only want to change this, but not passing over here. So important things, area 2D is different from rigid body. So area 2D won't actually have the slide or those kind of methods. You see area 2D have some things here, but in my case, I'll change it to the second layer. And since it's just below my character and not to the sides, it also means that this area 2D will only be able to collide with things below it. So if I save here and come back here, you can also see the little area here and run. Everything works perfectly fine. You see my character goes like to the bottom. It's not trying to make the area 2D appear as well. But in my code, I can actually check if that area 2D is being collided. So if I click on the area 2D, come here in the node, and I can say if area entered, sure. So I'll just print something out here. So I'm connecting a signal from my area 2D and checking if something entered this area. If I run here now, I think I have more things printing though, so let me just remove this. And one little correction here, the area entered, if you hover over, it'll say that this signal is emitted if this area enters another area, but the tile map is not an area, right? It's actually a body. So we're actually using this body entered, and we can also use this body exited over here. I'll just delete this one because I don't actually need it anymore. Make sure I remove from here too, disconnect. And from here, I will print here. If my character hits the ground, it'll say I hit TileMap. If I jump, it'll say it again. And hit, jump, hit, jump. So now instead of doing this little complicated thing that I did over here, I can actually just say I am on the ground if I enter the body. Am I off the ground if I exit that body? So I can remove this. I only do this if I'm on the ground at first, or I continue until I hit the ground once again. So instead of doing this, I'll say I'm on the air basically. Or in other words, I want to run this portion of the code, which is the logic that I'm going up while I'm pressing up and starting on the ground. But then I need to continue running this while I'm on the air and still pressing. Once I release it, which is this, I actually want to say, okay, now that I released, I can't actually jump again until I reach the ground once again. So let's do this now. The solution that I did was very simple. I created a new variable here called jumping. So say I'm currently in the middle of the jump. And if I'm on the ground or I am jumping, I do this. If I'm doing this, then I'm jumping again. If I release my up, I'm not jumping anymore. So it means that I need to wait to be on the ground once again to be able to jump again. So if I run this, I can jump from the ground, but not in the middle, and also not from the sides. So I just barely can make through over here. And now you see the next step of our tutorial, which is handling the camera. I want actually to move the camera with the character that we have now. And to do that, we are going to use another node called Camera2D. You can just add a Camera2D. You'll notice that the bounding box of this Camera2D is very similar to the one that we were seeing before in the viewport. To actually use it, you can just select it and come over here and say current. You can only have one Camera2D active at a time. So if you run it like this, now the camera is just showing this portion of the screen. But now, instead of just showing this portion, we actually want to follow this camera to follow this little character here. And if you remember from our second episode, we can actually use the scene tree to pass on what is the position of things onto its child. So if the camera is actually a child of the character, and we make sure to change here in the transform position of the camera back to 0, you'll notice that now the character is centered. And if you run it, if you run the project, here we go, the camera is now perfectly following the character. You can also give a little bit of margins to the camera over the settings over here. Feel free to mess around however you prefer. There are several tutorials of how to use cameras, but in our case, I'll just switch this a little bit around and make the game a little bit more fun to use by selecting these two drag margins over here. And that's all. You can change a little bit of the configuration of what this drag margin is. But it basically is an area where the player can move, where the camera actually doesn't move. It's very good to have a simplistic way of moving the character. So finally, let's do the end, which basically means I want the character, when it reaches over here, just pop up something saying game over or something like that. So to do this, let's create, say, an area 2D where I will detect if my player reaches over there. So just get it, make sure to move it over here. I need to add a collision shape. The collision shape will be, rectangle. Hit over here. And this is my goal. So just to make everything well structured, instead of just leaving this in my node, I'll create a separate branch saying this is a goal type. So in my goal type, there's this thing which, well, we'll need to move back to the origin. Just move back to the origin. This one needs to move back to the origin as well. And let's draw something new here to represent a goal. Maybe a little flagpole. I don't know, something like this, and maybe this is enough for now. I'll just save as goal. My little flagpole is saved. And I can load it from here once it actually appears. Did it appear? No. Save as. Well, oh yeah, I forgot to click on PNG. Goal.png, save. Notice that sometimes you need to just do some alt tabs to make sure that this little file system tab gets updated with whatever changes you do, because it doesn't update every time. I'll just drag it onto the scene, and once again this little thing should be on at least near the middle. I'll move up. I'll also make sure that it's not filtered, re-import, because I want a pixelated view or way of showing things, and I'll make sure this is correctly matching my flag. Maybe something like this. Yes, this is good enough. My goal will have, I don't actually need to change this, but let's say it's the third layer and mask. If I save here and back on my main character, I can say if my character hits this third one, I also want to check for collisions. So let's go back to my main scene. Now I have my goal, which is back over the origin. Just move it over here. Maybe scale it a little bit to transform 3 and 3. And now if this goal works, I'll create a script in my main scene to receive whether the user arrives at the goal. So the goal will receive a body entered. We'll go to the main, and I'll just for now print what the body is. So now if I run and go here, and I see over here my body 2D appearing. And to end things up, let's make so that when the character arrives in this area, instead of just printing things out, we actually show, I don't know, like a "you win" screen or text hovering over the, I don't know, wherever the character is. To do any kind of GUI or UI in your game and making sure that it matches wherever your camera is. So notice I'm using a camera right now. So to make sure this is actually matching well, what we do is add a canvas layer. So this canvas layer makes sure, I'll just make it the first child just because I prefer like this for organizational purposes. I make sure that this canvas layer will appear with whatever is inside once this character actually arrives over there. So what I'll do is just add a control type node, where I have not talked about the control type node very much in the beginner series, but if you look at other tutorials that I have done in YouTube, you might learn a little bit more about different control nodes. So basically, control nodes handles user interface. As you can see here, all user interface nodes inherit from control. A control's anchors and margins adapt its position and size relative to its parent. The main purpose of the control nodes and everything that is inside here is making a UI. And this UI will be inside the canvas layer, just to make sure that all the UI I want to make appear in the screen will actually show exactly where the screen is or where the camera is, and not just in one position of the world. So inside the canvas layer, I'll add a center container. This will be the first node that I'll talk about, which is very simple. It's just to make sure that everything inside it is centralized in the very center, horizontally and vertically. You'll notice that the center container here is fairly small. So what I'll do is just come to layout and say full rect, so that this center container will match the size of my viewport or the size of the screen that I have. And inside this, I'll add a label. So label is just a way to defining text in Godot. So I'll say here, you win. So if I just run the code like this, you'll see a you win in the center of the screen. I don't actually want you win to appear at all times. So what I'll do is click this little I button here, which makes the node be hidden. You notice that I actually can do this with anything that I have in my scene, not just control nodes. And what it does internally is Godot has this hide and show functionality. for all canvas items. So you can see here, every canvas item has a show, as you can see here. So it basically shows if the canvas item is hidden, and hide, which actually hides the canvas item. Here it is. So it hides the current canvas item, which basically is the same thing as toggling this through code. So this is what we are actually going to do. So here in main, I'll make sure there's another script over here. And when the user actually gets to the goal, so come here and use this body entered. I just create another one here in main. And when the user gets to the goal, what I'll do is enable this center container over here. Obviously, the best thing to do here is just put names, better names over here. I'm not doing just because it's easy for you in the video to know what are the types of each of the nodes over here. So here, what I'll do is using $, I'm able to access everything that is within the scene tree. And I will go to the label, not to the label, sorry, to the container and do show. So now the uwin is not showing. If I actually get there, uwin. Now we have finalized the level with the end goal, but we are actually not dying. Notice that if I fall here, I don't die. I fall to the infinity and beyond. We're not actually going to implement this in this video, but the next video we will be working on enemies dying, reviving, and lives. So see you next time.